You know that feeling, right? You're booking tickets for a huge blockbuster the moment they go on sale. You click on the perfect seats and you can't help but wonder, what's stopping someone else from grabbing that exact same seat a millisecond after you? Well, let's dive in, because the system that prevents this kind of chaos is actually pretty brilliant. So here's the scene. It's the ultimate digital standoff. You and some other person clicking on that perfect center aisle seat at pretty much the exact same time. It feels like this high-stakes race, but behind the scenes, there's no race at all. There's a system. So we're going to pull back the curtain on how these online booking platforms have totally mastered this problem, making sure your experience is smooth, fair, and completely free of any seat-stealing drama. All right, the whole solution actually hinges on a really simple but super powerful idea. Every single seat can only be in one of 3 states at any given moment. This is the bedrock of the entire system. The flow is pretty straightforward. A seat starts out as available, obviously. Once it's booked, it's gone. But the real magic is this middle step, locked. Think of it like calling dibs. It temporarily holds the seat just for you while you handle the payment. And as you can see, if something goes wrong, maybe your payment fails or the timer runs out, the seat doesn't get stuck. It just loops right back to being available again. Okay, so that's the theory. But how do these states actually work when you're booking for real? Let's walk through the happy path, when everything goes perfectly, from the second you click to the moment you get that confirmation. Check it out. It all starts when you select a seat. Instantly, the system checks its status. If it's available, it's immediately locked, and a little timer, maybe 5 or 10 minutes, starts ticking just for you. Right away, the seat map updates for everyone else, showing that seat is now off the table. This gives you your own private window to pay. Once that payment goes through, the seat status changes one last time to booked. See? Simple and elegant.
Okay, now for the main event. Let's get back to our original problem. 2 users, 1 seat, and what feels like the exact same click at the exact same time.
This is where the system really proves its worth. I mean, even if those clicks are just milliseconds apart, the system has to declare one clear winner. So, how does it do it? This is first come, first served in its purest digital form. The server is incredibly fast, and it processes requests in the exact order they arrive. So, user A's request hits the server first, the system sees the seat is available, and bam, acquires a lock. Milliseconds later, when user B's request comes in, the system checks again, but this time, it sees the seat is already locked. So user B is immediately told the seat is unavailable. No battle, no double booking, just a clean, decisive resolution. So we've covered the what, but now let's talk about the how. What kind of technology is actually making all of this happen so fast and so reliably? It's time to look under the hood. At the core of all this is a technology called row-level locking. So imagine a giant spreadsheet with every single seat in the theater listed. Instead of locking the entire spreadsheet when you pick your seat, the system only locks the one single row that represents your choice. This incredible precision is what lets thousands of people book tickets to the same movie at the same time without grinding the whole system to a halt. But, a huge site runs on hundreds of servers at once. So what happens then? Well, that's where distributed locking comes in. A system like Redis acts as the ultimate referee. It's the one single source of truth that every single server has to check with before it can lock a seat. This makes sure that a lock made on a server in one city is respected by a server in another, guaranteeing total consistency. Now just picture it. Tickets for the biggest movie of the year just dropped. Millions of requests are flooding in all at once. To handle this kind of chaos, systems use message queues. Think of it like a super organized waiting line for booking requests. It makes sure every single click is processed in the right order and that nothing gets lost. And you know how the seat on your screen turns gray the instant someone else locks it? You don't even have to refresh the page. That little bit of magic is thanks to WebSockets. It's a technology that creates a constant two-way connection between your app and the server, letting the server push updates to you in real time. It's pretty cool. Okay, let's put it all together and follow the entire journey. It starts with you, in the app. Your request goes to an API gateway. Think of it as a traffic cop. It directs your request to the right places, the inventory service, and the lock manager. They talk to the database, update the seat status, then hand you off to the payment service. And finally, a confirmation comes all the way back to you. It's like a perfectly tuned assembly line. And finally, making this system truly foolproof comes down to a set of core engineering principles. These are the behind-the-scenes rules that guarantee data never gets corrupted, that abandoned seats are always released automatically, and that the system never gets stuck in a digital traffic jam. They're the safety net that ensures this process works flawlessly every single time. And there you have it. From a simple three-state system all the way to a sophisticated back-end architecture, that is the elegant solution that turns potential booking chaos into a seamless, fair experience. So the next time you book a ticket, you'll know exactly what kind of magic is happening behind that single click.